gets very exciting. The first thing we're going to take a look at is ES6. Okay, ES6 is the 6th version of the ECMA script implementation. ECMA script, if you remember way back when we first introduced it, is JavaScript, right? So JavaScript, the formal name of the language is ECMA script. ES6 is the 6th version of it, and it comes with a whole bunch of new things that make coding a little more interesting and exciting for us. And so all the stuff we've been doing up until now still is valid to do in ES6, but with ES6 we get a whole bunch of new constructs that you will see very frequently as you become a web developer. So we're going to introduce them now. The first is let and const, right? Let me close this down. Let's see. Bloop. Where is my editor here? Perfect. All right. So I'm going to make a JavaScript. Let's just launch this. We'll play inside of the file page es6.js. Cool. And I'm going to put this in the page with script source equals es6.js. Okay. Put some stuff in here. Week 6 script. Week 6 JavaScript. Oh, my chair is tilted too far back. It's driving me crazy. All right. Cool. So if we load this page, open with live server. Perfect. So here we are. Pull up my developer console. So up until now, we've been declaring all of our variables with the var keyword. We would say var first name equals Eric, right? And that has been the way we've declared variables in JavaScript for years and years and years. Okay, that was like the official way. That was the only way. But ES6 gives us these two new ways to declare variables. The first one we're going to take a look at as let. And so it's let last name equals Harrison, right? It's doing the exact same thing, right? First name is a variable. Last name is a variable. Everything that you could do with var, you can do with let. So I want you to just, right off the bat, like think of this as like a drop-in replacement. But one thing that's interesting about let is that it does not let you overwrite or create a new declaration, right? So we already have first name here. We declare it with var first name. I can say var first name equals Meg, right? And first name is now Meg. It has completely overwritten our variable. If I was to try and do the same thing with last name, Steve, right? Oh, it's not going to do it here. Last name. Yeah, we have to do it inside of code. So let's do this in here. So I'm going to say let first name equals Eric, right? And then right below it, I'm going to say let first name equals Meg. And this should, it's going to give us a syntax error saying that the first name identifier has already been declared, right? We can still use this as a variable, right? In our code, right? If we look at first name now says Meg because our code has first name saying Meg. But what this does is it will let you write more efficient code and protect yourself from making accidental mistakes. If you can imagine, let's open up our code from earlier, our to-do list app, right? Save. So if we open up our to-do list program, right, you can see that we have all of these variables in here. Let's say we declared lists with let. Okay, so we declared lists with let now. If I was to come in here accidentally, way down the page, and say, let lists equals something else, right? This is going to protect me from accidentally overwriting a variable that we care about, right? So this is a very good way to protect yourself from making accidents, right? It's going to tell you, hey, our list program isn't working because we overwrote that variable. So it's letting us know we made a mistake. We declared something once, and then we accidentally declared it later on. Does that make sense to everybody? Yes? So I want you to get in the habit of using let instead of var. There are a few scenarios in which using var is useful, but in this day and age, it's probably better just to go straight to let. Get used to let. I fought against this for years just because I'm so used to typing var, but let is a far superior way to declare your traditional variables. Functions, arrays, objects, and strings and numbers, right? So instead of saying var, just get in the habit of saying let. You're going to see in older code most people are still using var, especially a code that has existed 5, 10, 15 years that have been around for a while. A lot of people still use var. But as you start to transition into your careers working as professional software engineers, most of the modern libraries and bits of code you're going to use are going to be using let instead of var. And so just getting that into your head, knowing that it's the same thing, but let is a little bit more protective, right? The other thing, there's another kind that we want to take a look at. Let me pull up the open week 6. Good. There's another mechanism here called const. And this works just like let. Okay? So I can say const first name equals Eric. Let me take off. Here, let's get rid of that guy. All right. So const first name equals. Oh, I gotta turn that thing on. Go live. Okay. If we look at our developer toolbar, we can see that first name equals Eric. But this has an extra special feature, which is I cannot change the value here. I can say Meg. And it's going to say assignment to a constant variable. So we use constants for things that we want to enforce won't change. We want to enforce that the value will not change. Things like settings, things like arrays of options, right? So let's take a look with an array. Let's make an array. Yeah, and we'll just put Eric in there, right? So now we have first name, which is an array. If I was to do first name dot push Eric2, right? First name allows us to keep putting values into this constant thing, okay? But we cannot change it from being this array. I cannot say first name equals square brackets because now it assumes that the array that was created when we called const first name equals array, that is the array it has to remain forever. We can change values in here. We can say first name dot pop, first name dot pop, call again. And now if we look at first name is empty. It's still an array, but we cannot change it from being that original array. I can't turn this into an object. I can't accidentally say this now says Eric. So we're going to use constant, the const keyword, to declare variables where we want to enforce that they cannot be overwritten. It's great for strings, it's great for numbers, but really where it shines is in things like arrays and in things like objects. So we can guarantee that even if somebody goes in there and removes elements or add elements to our array, it's going to be that same array all the time. And that's the const keyword. Does anyone have any questions about that? A great example, and where you'll see this used pretty frequently in, I should have just kept that other page open. Open new window. Open folder. If we look at our to-do list app here, generally where you'll see const used is in when you're ingesting information from a third party, right? So like in this example, when we implemented our local storage to be our database, right? Rather than having this be a var, we would come in here and say const local storage, storage list equals local storage get item. So storage, this is going to return a string to us, and then you'll notice like we don't want that to ever change. So then we would maybe even say, we could not put const here. Right? We could not say that this is a const because we're declaring it as an empty array, and then we're trying to assign it. We're trying to use assignment to say the array equals now JSON.parse. So that would break. So we want to use let here in the places where we know we want to do assignment, and const in the places where we know that we're not going to ever change this again. Right? Storage list is going to be storage list forever and ever and ever on down through here. Does that make sense? So the two new things, right? We learned about var equals old way to declare variables. Let equals new semi-protective way to declare variables. And const equals new way to enforce my variable will not get overwritten. Okay? Let, var, and const. I would be willing to bet, based on seeing how JavaScript has been changing over the last really 5 years, that there will probably be in the future more ways to declare variables. For those of you who have had experience with typed programming languages like C++ or C, we will probably at some point see something like like an int that enforces it to be a number. We might see, floats. We might see strings. Those don't exist yet in native JavaScript, but there is a language that is developed called TypeScript that introduces some of those types of things into JavaScript. If I was betting, I would bet that at some point in the future you'll see those ways to declare variables being entered into the language. They will probably still keep var, let, and constant, but what I can imagine would happen is that if we said int, age equals 37, right? If you tried to say age equals Eric, it will say, hey, this is illegal. You can't put a string in a number. Just be aware that might change over the next couple of years. So just be aware of it. All right. What else? Cool. The other thing that we have that ES6 provides us is that up until now, when we're working on strings, we would say like let first name equals Eric, right? Let last name equals Harrison, right? We would write our code if we wanted this to print this out to the console. We'd say stuff like console.log hello plus first name plus space plus last name, right? That was kind of the old way we would manipulate strings and put variables and things. ES6 gives us a really cool feature called template literals. And what it lets us do is that instead of saying like this, where we're adding a bunch of strings together using string concatenation, we're going to have this new format, right? This is a single quote, right? A single quote. If we write our string using backticks, which is the number that should be directly to the left of your 1, right? So this is a backtick. I can say hello, comma, and then anywhere I want a variable to go, I can replace it with a $, and then the letter, the variable name, and then a $, and the other one, last name, right? This is the template literal syntax. And what this will do is that it does exactly that inline string replacement. So the variables are getting replaced in line. So this is much cleaner and lets us write clearer strings, and it's very easy to see, hey, this is a variable that's getting put in here, rather than trying to hunt down, like, did I forget a plus sign somewhere, right? Throwing off some weird error in the browser. Both of these syntax are still good. I use, just through habit, through muscle memory, I use this syntax far more often than I use this syntax. But generally, when I'm halfway through coding something, I'll be like, oh yeah, I should use this one better. So that's just a habit I'm trying to break of myself. I would encourage you, when you're dealing with strings and variables like this, to just get in the habit of using the backticks so that you can have them be template literal replacements. Now, the only time where this doesn't make sense is if you're writing a string that just says, a string. Right? If it doesn't need variables to be put into it, just use single quotes. Treat it as a string so that the browser doesn't have to go and figure out. Because what's really happening behind the scenes here is when it gets this template literal, it's saying, okay, I have to do something here. And it has to first parse out the variables placeholders, then put in the variable. So it's doing all this manipulation behind the scenes. I would be willing to bet that if we were to get in there and profile the amount of time spent, right? This is probably going to take 30 milliseconds, and this takes 1 millisecond, right? So maybe even an order of magnitude faster just to use a string when we don't need to swap out variables and stuff. Okay. Any questions about the template literal syntax? It's backticks, and you can use this for anything, right? We can say my message equals, right? I'm putting in the backticks here, and in between there, I can say this is inside a template literal string. I can put in variables with $, first name. Okay. And if we were to look at my message right now, right, you'll see that when we actually look at that string, by the time this has been executed in our browser, the string has been replaced. Right? I can put in variables. You'll see that this already says Eric. As soon as the template literal is declared, it's basically a shorthand for saying, hey, generate a string and swap out whatever's here. Okay. What if we put in, let's try a template literal string with a variable that doesn't exist. Let's test that and see what kind of error message that will give us. This is a template literal string with a, let's call it broken bar. Okay. Okay, so it will give you a undefined message. If you try to use a variable name that doesn't exist, you're going to get that same type of variable message that you would get if we tried to use it in some other place. So that's pretty good. Any questions about template literal strings? This is super powerful. I have been trying really hard over the last 2 years to beat this into my memory so that I stop doing things the old busted way where I'm having plus signs all over the place. No questions? All right, this one's gonna break our brains. Okay, so up until now, right? Let's give ourselves a little bit of space here. Functions. The traditional way to define a function, we really learned 2 ways, right? The first is a named function, so we'd say function, my func, right? And we would say something like console.log hi, right? So this declares the function my func. We also learned that we can use the alternative syntax where we say var, my func equals, and then we use the anonymous function, the anonymous style, to say I want to take this anonymous function and store it in the variable my func. Okay, these are both going to create a function called my func. It's just the style that we're declaring this function is up to us, right? And so then we can come in here and say console.log hi. Okay, so my func, right, is that one. Is this one that we just wrote, because when we created the function this way and we called it my func, this overwrote it because there's a name collision. Okay. ES6 has introduced an entirely new format for functions, and it's wild. Okay, and so what that format is the arrow function syntax, and it starts like this. You would say, it starts with parentheses. Okay, so any arguments that you want the function to have, like args. Okay, then it has an arrow, which is equal sign, greater than sign, and then curly brackets. Okay, so right now this is an unnamed anonymous function that takes 1 parameter arguments and does nothing. So we could come in here and say console.log hi. And if we wanted to put this into something we can use, right? We can declare it the same way. We can say my func2 equals, right? So you'll end up seeing code that looks kind of like this, kind of wild, where it says my func2. Here, let's use this as a real example. So I'm gonna call this variable string, and I'm gonna come in here and I'm gonna use our template literal syntax to say hi string. Okay. So we've got a function now called my func2 using the arrow pointer function syntax of ES6, where we don't have to put the word function anywhere here, right? So this is the same as us saying function, whatever. Okay, but when you put in the keyword function, you can't use this syntax. So why would we want to do this? My func2, and we put in Eric. Right? So every time I call this, it's going to call hi Eric. Okay. This is extremely useful because there's another wild thing that it does here as well. So let's do var add equals. We're going to do num1 plus comma num2. Right. So we're going to make another function called add. And what we're going to do here is we're going to say num1 plus num2. Okay, that's pretty wild. I don't have any curly brackets in here. But what this syntax lets us do when we don't put curly brackets in here is that it's going to run the expression and return it. So when I call add, the return of this function is going to go back out to whoever called it, right? And so the way you would write this the old way would be like var old add equals function num1 comma num2. It would be the same as us writing return num1 plus num2. So when you do not put curly brackets in here, it's going to take whatever the single expression is and have that be the return of the function. So if we go in here and we just verify that this is working, we can say add 5 plus 10 should be 15, right? It's the same as old add 5 plus 10. And the way we use this, normally when you call a function, we're going to restore it as like sums equals add 5 plus 10, right? So sums is the value of 15, whatever value was returned from that function. Okay. Um, a lot of the reason that this style was built was to be used and useful to let us write one-liners in a lot of our array functions. So like sort, for example, right? If we, let's make an array. Var nums equals 5, 12, 2, 7, 13, 27, right? So we know, right, nums, if we look at nums, right, there is a sort function that exists on the array, nums.sort, that takes a function, right? So we were writing this the other day, we'd say a, b, and we return a is less, a is greater than b, right? Stuff like this. Right? Remember, because this function takes, the sort function takes a function that has those two values and it returns whether it's greater than or less than, right? So if it's a 0 or 1 or a negative, right? So that's how it sorts the array. With ES6, right? I'm going to redeclare this variable, right? So nums is crazy again. This was how we wrote these functions in the old way. With ES6, we can say num sort a, b, a minus b. Okay? It's going to do the exact same thing because it's the arrow function syntax. We don't have to put the word function. We put a and b, those are our two arguments, and then after the arrow, we say a minus b. So it's returned. If we wanted to, we could use curly brackets still, but as soon as you do that, this arrow function doesn't return anything unless we tell it to. So if I wanted to use curly brackets like this, then I would have to say return a minus b, just like the old days. This syntax lets you write much cleaner code, simpler, right? It lets you use functions and callbacks in places where it's required to be in here. Now, this syntax is super wild, right? I have never written code like this. This is something that is unique to JavaScript, as far as I know. It may exist in some other languages like Haskell or Haskell or some of those other ones. I don't know where they got this idea from, but once I embraced it, once I got used to seeing this around, this has saved me, over the last year, probably 300 hours just of typing alone, because you're going to write functions all day long, every day. And switching to this syntax saves you the word function, return statements, and it lets you chain code together in a much cleaner, simpler way when a function just needs to be able to decide, is this number bigger or smaller than this other one, right? In this exact type of example. So, right, I'll put this in here as a var nums equals, right? So I'm going to have all this as an example for us. I'll just copy this. Okay. So the old way would be nums.sort function a, b, return a minus b. Right, that was what we learned last week. The new way would be nums.sort a, b, a minus b. Okay, so that shaved off what? I don't know, 15, 20 letters. And if you're typing this type of code all day long, it'll save your life. Okay, you just figure it out. Like, if you spend 30 minutes a day typing these words, function, AB, whatever, return, all that stuff, well, 30 times 5 days a week times, 52 weeks a year that you're going to be working, that's like an entire extra day of sleep you get, right? It adds up. So this syntax is beautiful, even though it will probably take you a little while to start trusting that it's working, because it did for me, and I've been doing this 20 years. You will, when we start working in Node, we start doing stuff on the back end, we start working with NPM, which is Node modules, so that's open source code that people have written for us. Almost all of the examples and all of the code that they write is going to be using this type of syntax. I do not see in the JavaScript open source environment kind of movement or culture anymore very many people writing these types of functions anymore. I don't see this as often as I used to. It almost feels like, at some point a year ago, everyone just decided we're going to switch over and all of our code is going to look like this. So get used to seeing a lot of arrays defined like, var, or a lot of functions defined like var, do something cool equals like, first, last, first, last. Okay. Who can tell me what this code is going to do? Go ahead, Kareem.
It's gonna place the first and last name. It's gonna replace the. Okay, hold on. Okay, the dollar sign curly braces is telling the first name that it's gonna replace itself whenever you see that in a function.
Mm-hmm.
I can't explain it, but I know what it's gonna do.
So
It's gonna place
what are we declaring right here?
that first and last name is do something cool.
No. So when we say var do something cool, like we're creating a variable, right? And
Yeah,
what are we putting? What is the name of this? What is this highlighted block of code? What is that?
that's the function.
That's the function. Yep. These are the arguments, and this is the return value.
Okay.
So we just created a function called do something cool that takes a first name and a last name and returns a string that has first name and last name put together.
So we call it return values.
Yeah, return values. So
Return value.
this is what this will return. If we do something cool, right? That's our function. And now I put in Eric and Harrison. It returns the string Eric Harrison put together using that template literal syntax. Now, you'll see even code that looks exactly like this pretty often, where first name and last name are in here, but maybe they want to change this to say last comma first. And if we do something cool now, Eric Harrison gives you Harrison comma Eric. So people write these types of functions now for all kinds of things because it's easy to do it in one line and it doesn't take up a whole bunch of space. If I wanted to make some, first last name presenter type of thing, the old way of doing this, new way, would be I'd have to write a function, do something cool, old way, first comma last, and then we'd have to say return, last plus comma plus first. Right? So it takes up 3 lines of code. I'm using the old type of syntax for the strings instead of using a template literal. So I would almost never go to the effort of writing a function to do this. But with this new way, it's so easy to do this in just one brief line that I'll use this all over the place. And when we start doing back-end JavaScript, we start working with templates. There's so much cool things you can do with templates using this type of function format, where you just write it in one line. It's going to feel super natural to you, and you'll be like, oh, that's super cool. We'll point out those examples when we get into EJS templates for the back end. Any question about this syntax specifically? Go ahead, Olivia.
Sorry, I'm confused. So why did you use var? I thought we were supposed to use let. No.
They do the same thing.
I know, but you just did it for whatever.
Yeah, it's muscle memory.
Oh,
When I think of creating a variable,
cool.
I type var. My fingers move without my brain being involved.
Okay, that's
Yep.
fine then.
Perfect. And part of the reason why I have to pick var in some of these examples is that I'm reusing the names to show that they can be changed and stuff. So like up here where I was saying var myfunc, I was renaming this function myfunc. If I used let here, it would throw an error and say, hey, you just redeclared a variable, right? So I'm also trying to prevent that a little bit. Because I'm going to check this all into version control, so you guys will have this as a reference to look at a couple of the different things that we're doing. Okay. Functions. Cool. Any questions about this? No? All right. The next cool thing we're going to look at is the REST operator. Okay? And what the REST operator does is that it's a cool method for our function parameters. So I'm taking a REST operator. Okay? So let's say we have a function, and we'll say function. Let's use the new syntax. Let my ages. Let's do average ages equals, right? And we're going to put in age 1, age 2, age 3, right? But I want this to keep going regardless, right? Maybe I'm expecting more things to be put in. What I can do here is with the REST operator, I put in three dots, and I can say the others. Right? Oh, I forgot my arrows. Okay. So what this does, if we console.log age 1, age 2, age 3, and then we say, let's log others on its own. Console.log others. Okay. So if I'm in my code here, and we say, what do I call average ages. Okay. And I put in, 5, 10, 15, and then I'm going to keep putting in things. I'm going to say, Eric, 27, whatever. Okay. The others. The others. All right, so I'm going to call this again. Right. What it does is it takes any extra arguments that are passed that aren't declared in here, right? Age 1, age 2, age 3, and it takes all the rest of those and puts it in an array for us. Okay. We already kind of have that with the arguments array, right? If you remember when we were looking at arguments, let args equals, right? If we put nothing in here, or if we put age 1, and then we do, right? And we say console.log age 1, and then we do console.log arguments, args func, and we'll put in 5, 10, whatever, Eric. Arguments is no longer defined if in this syntax. That's interesting. So let's change this to the old-fashioned function. So that's why. What is it called? Args func. 5, 10, Eric. 2700. Okay. The arguments array that exist in the traditionally defined functions kind of had that same purpose. For whatever reason, when they changed this arrow pointer function syntax, arguments no longer exist. They expect you to use things like the spread operator, where it's 3 dots, and you're saying any other arguments that are passed into here put into this array. But arguments was doing a very similar type of thing for traditional functions. And so if you wanted to let it have any number of arguments, you can always grab those out of the arguments array. For ES6 specifically, in the arrow pointers, arrow functions, you have to use the spread operator. 3 dots and then a variable name. So this is going to say anything else that is put in here, slurp it up. And so what you will often see is instead of arguments like this, you won't even name your arguments. You'll just say any number of arguments I want to put in the others array. So let's just call this ages, right? Ages. And so if we call average ages now, we do 5, 10, 15, 20. Our array, this is the ages array, has all of those values in here. So we can take any number of arguments and do something with them, right? And what we would do for averages, right? We'd probably, say let average equals 0. Okay, and then, to add these together, what would we do? We'd say ages dot for each. Or we maybe even do like reduce, ages dot reduce. And here's another perfect example of where we could use ES6, right? Because reduce takes the total, right? Total and the current, right? And returns total plus current. Okay? And so we can just assign this var total equals that. And then all we have to do to get our average is, all right, let's use let here. I did it again. All we have to do to find the average is return total divided by ages dot length. Right? And so now if we put average ages and we call that, the average age is 12.5. This type of syntax, combined with the rest operator, lets us really efficiently write very cool functions, right? We could reduce this entire function using ES6 into just one line, right? We can say average, I'm going to give this a different name so that we don't have issues here. Let av ages equals ... ages. Then we do arrow pointer. And if we don't put brackets in to our syntax, we can just, whatever we want to do here is returned, right? So this is perfect for these types of functions where we're writing code that's going to take some number of values and return some type of array, right? So we could do ages.reduce total cur I need extra thing in there, right? Tot plus cur. Okay, so that's going to come out of ages.reduce divided by ages.length. Right, so in one line, we wrote a function that uses a function for an array that returns our average ages. Right, and if I do average ages, right? 5, 10, 15, 20, right? We've just written a very efficient line of code. It's kind of wild, but these are doing the exact same thing. It's the exact same code. We're saying, hey, because we are not using curly brackets in here, whatever this statement is going to return. Right? That is the value that is passed back out of the function average ages when we call it. It will take any number of numbers and return the total plus the length. And so this inside of here is its own separate function, right? Using the same syntax. Any questions? Go ahead.
When did you designate current, or it became current when you typed it into the function under the console?
It's literally right here. When we write our function, just like with the old way of writing functions, whatever we name our things in the parameters, in this section here between the parentheses, is the name of the variable that will exist inside of the curly brackets, or in this case, inside of the statement, the arrow statement, right? Does that answer your question?
No, my question is, how does it know what's current and what's total?
Like how does inside this reduce function?
Yes, that's just
how the reduce function works. The reduce function, when it's like a for each, right? It would be similar to like if I wrote a function called do the thing or process array, right? Someone has written a function called reduce that does basically this, where it says like total counter and then current value, right? And so every time, and there's maybe even like a third one. You guys don't know about this yet. So that's just the syntax of reduce, is the short way to say this, is that the reduce function by itself takes a function that expects that the first argument is total and that it returns some combiner, right? We're saying total plus current. And then the next time that it calls on the next element of the array, it's going to pass in the total that was returned from this one. All right, so as it's looping through the array, it's capturing that value. Oh, I could probably write it. Let's see.
I guess my question is, how did you know to place current inside of the brackets? I understand total, yeah, but why that variable?
It can be called anything I want it to be called. It doesn't have to be called current.
Okay, that answers my question.
The second parameter to the reduce function here is the current item, right? So you can imagine this is an array of numbers, right? We passed in, 5, 10, 15, 20, 30, right? That is an array. When we call reduce, it's operating on each element in that array line by line. So it starts out at line, let's say, like right? For ages equals 5, 10, 15, 20. The first time this runs through this, it's going to say, all right, I'm going to call this function. Let's call this Adam. And we'll do total current return total plus current. Right? So this is all this function is doing, right? Whatever is passed in here is returned out, right? So when we say, the first time this runs, it's called Adam, and then it says 0, 5, right? That's that first element. Right? So that's going to return 5 to us. Then it's going to go to the next element in the list, and it's going to say 5, right? Because that was the previous value, comma 10. So now it's 15. Then it's going to take 15, and it's going to say Adam 15, 15, 30. Then it's going to say Adam 30. What is the last one? 20, 50. That's exactly what ages.reduce total tote plus cur. That's exactly what this is doing. It's going through each element of the array. It has its own internal tracker of like the total value or the total item. It's called what is it called? It's like called an incrementer or something.
Yeah, I understand how the reduce function worked. I'm just curious as to the variables you use, total and current. Those are just two random variables that you picked and placed in there, right?
Yes.
Yeah, that was my question.
Yeah. Anytime, and this is really important, thank you for bringing this up. Anytime you're writing a variable, I am the one choosing what that variable is going to be called. If you see something in light blue in here, I picked it, for the most part. Like dot length is a property, so somebody else picked that. But whenever we're writing our own functions and parameters here, right? Cur. I'm the one who decided that that's what I was going to be used, because I'm going to then use that same variable inside the function.
Okay, got it. That was my question.
Okay. Yeah, sorry it took a little while to understand what you're asking. And generally, when it comes to naming variables, my one piece of advice that I would encourage you to do, because you can kind of see the problem here, is you want to pick a name of your variable that makes it clear what's going on there. Right? So I'm saying this aloud, tot, cur, right? Those are really bad variable names. It should probably be total and current, but I didn't want to type all that out. So just make sure you're doing whatever it is so that when you read your code in the future, or when somebody else reads your code, they understand the intention of what you're trying to accomplish. Okay. Go ahead, Josh.
Hey, I think, at least for me, I don't know for Karif, I think some of the confusion, at least sometimes, is like when we are calling functions or like well-known functions like reduce, like sometimes it seems like you don't have to put any arguments in there. And then sometimes, like, I guess maybe learning that, like, oh, reduce, you have to put in the total and the current value as arguments. So is that just something you just got to learn through time? Like, hey,
it's
this
a
one's
practice
gonna
and repetition thing. And I'm going to be honest with you, I don't remember most of these. When I'm not teaching this class, I very rarely use dot reduce or dot whatever. It's just not in my repertoire, because most of the time when I'm working with arrays, it's never very simple arrays like this where I just need to combine ages together. It's like arrays of to-do lists, and I don't need to reduce them. I need to do stuff with them. I need to like put them on a page or implement them so that they're clickable, right? So when I need to learn how do I write this, if I ever needed to do so, I'm going to do the exact same thing I would encourage you guys to do. Array.reduce JavaScript. Right? And I'm going to click on the first link and come in here and play around with it, right? So Mozilla.org says, hey, previous value, comma, current value. That's the variables they picked for theirs. And you can see here they're using ES6 in their examples. That's one of the reasons we stay away from them in the first couple of weeks. But you guys, now that we've learned what we learned today, you should be able to say, okay, they're making an array called array1. They put in 4 numbers in here. Then they're using ES6 function syntax to say, hey, my reducer is previous value, current value, and it's returning previous value plus current value. And then they're saying array.reduce reducer. So they're passing this function into our array.reduce. Does that make sense? And they show you a couple of different examples, right? So this is like the arrow function method. This is the inline callback function method. It's all doing the same thing. It just depends on how you want your code to look, what the style will look like. And if we were to go to W3 Schools, for example, and look at their examples, array.reduce, right? They're giving you different, right? They use total and num. It's important that you know, like the important thing here, which kind of ties into Karif's question, is that these variables are always going to be different. It's up to whoever's writing the code to choose what they're going to be called. Does that make sense? So that's the
Yeah.
rest operator. Go ahead.
No, I was saying yes, it made
Oh,
sense.
good. So let's take a look at the spread operator. JavaScript spread operator. They're just showing you that like this ... is the spread operator itself, right? We used it in the previous example as the rest. So we said, hey, give me all the rest of the values. But this is the spread syntax. It's just showing that same thing. It's the dots. Cool. Object destructuring. What is that supposed to be? Oh yeah. Cool. So we'll definitely do this quite a bit when you're working with node modules. Let me see if I can find a good example here to come up with. Right. All right. Destructuring. All right. So let's say we have an object that says like info equals first colon Eric last colon Harrison, right? So this is our information here, right? What this new syntax lets us do with object destructuring. Let's see if maybe they have a good example on W3 Schools. JavaScript object destructuring. Yeah. All right. Cool. So you can do it with arrays and stuff too. All right. Yeah. Let's do it with an array. That's easier. Eric Harrison. All right. So let's say we've got an array that has my information, names. Okay. So that's our array. We want to get the first name and the last name out of here, right? We know we can do this the other way, right? Let first name equals. Oh, that's going to throw an error because we used it above. Let's say my first name equals names 0. Okay. And then we can do let my last name equals names 1. Okay, because that's the 0th index is Eric and the the first index is Harrison. Right. This is the kind of the traditional way of grabbing things out of the array. But what object destructuring lets us do is we can come in here and say let, and we put in our information here in brackets, and we could say my first name, comma, my last name equals names. Right, and so if we say my first name, it's use curly brackets instead of square brackets. Cool. Okay, and then if we do my last name, it's Harrison. So if you're using an array or you're using an object, we can declare new assignments from an existing array. So it's just doing the exact same thing. It's pulling this out of here. Does that make sense? It has destructured the object into individual variables. Right? So names was an array, and we've assigned my first name and my last name to be whatever the values were in those places. Right? And if we had more stuff in here, like let's put in a middle name in here. Middle name, Ryan. Okay. So now my first name, my last name is going to be Ryan because that's this middle spot. Right? if I wanted to skip over last name, I could just put a blank comma in here. Right? Skip the last name. And so now if we say my last name, it's Harrison again. We have, it's basically like a shorthand for exploding. Right? I just want to explode this array, and whatever the values are in the 0, 1, 2 position in this array, assign it to these variables. Any questions? All right. It is 4:55. We've covered a ton of crazy stuff. So let's take a break. Let's decompress, walk around the house or something, get a drink, and we'll meet back at 5:10. Okay? Let me start my recording. All right, cool. We're back. The last thing we want to point out is that with this new syntax for functions specifically, when we're working on these types of cutesy little one-liners, the ternary operator becomes even more important than it was before. And if you remember, the ternary operator was was a inline one-liner like if block, right? And so instead of saying if my first name equals Eric, return hello, else return you are a stranger, right? So that's our normal if block. The ternary operator, if you recall, was us saying my first name equals Eric, question mark, and then it was the true condition in here, true, false condition here. Right? So we could say question mark hello, colon, you are a stranger. Right? So this is a ternary. Right? This is extremely powerful with ES6 syntax because what do we need to do when we use? We want to have the short and abbreviated version. It's let name greeting equals right with the arrow pointer function, right? So it would be my first. No, let's just do my first name, right? So when we have this line of code here saying name greeting equals, right? We're unreachable. Am I unreachable? What are you talking about? What's wrong here? Oh, because we've returned already. Oops. So when we're writing this function, we're saying, hey, name greeting. When we use this little syntax, the ternary operator lets us get away with being able to return one or more values, right? So we can say, if your name is Eric, right, it's going to return hello. Otherwise, it's going to return you are a stranger. So if we were to run this code now, there we go, and we do name greeting Eric, hello, and if I put in, Meg, you are a stranger. So the ternary operator becomes extremely powerful and extremely useful using the ES6 syntax of coding functions. Before we move on, is there any questions in here? Anything that doesn't make sense? Anything you'd want to go over more? Because what we're going to do next is wildly different. Go ahead, Josh.
Yeah, I just, for I guess a little clarification, I don't know if you said this at the beginning, but whenever I'm looking up like some of this new ES6 stuff on W3 schools, everything before it is React mm-hmm. ES6. So is React like the new, what is that?
React is a web development framework built originally by Facebook to make them more efficient so they could write JavaScript code once and have that JavaScript create interfaces for them. The only reason W3 Schools is showing you React specific examples is because W3 Schools has a whole bunch of educational materials for web development, right? And so you're in the React part of their documentation, and React is entirely written in ES6. I don't think any of their JavaScript examples in here, this is from 2004 was probably the last time they updated this. And so all of this is using the old ES5 or 5th version examples. When you go to array.reduce, right? When you go to mozilla.org, right? Their documentation, this is just generic JavaScript. They almost always, by default, will show off ES6 syntax. They're going to show you both, right, using like arrow pointers and stuff. But almost all of their documentation in here is using ES6 syntax as their examples, which is the main number one reason we haven't been using Mozilla.org's documentation for the most part. Even though I think compared to W3 Schools, they do a better job of JavaScript documentation than W3 Schools does. It's giving you like the full, they give you still an example editor here. They give you some syntax examples. They give you a description. So like you can learn JavaScript just by reading this code, just by reading this documentation. They show you the actual language of the specification. If you wanted to go look up like what is the people that make the programming language, what do they say this is supposed to do? This is an excellent resource, but we've been avoiding it because all of their examples are all ES6, and they're throwing in things like const all over the place. W3 Schools is okay. They've been around for a long, long time, since early thousands. Any other questions? Cool. All right, now we're going to learn about object-oriented programming, okay? We've been playing with objects in JavaScript this entire time because JavaScript is fundamentally designed to be like an object-oriented language, right? So when we work on the document object model, right, it's right there in the word, right? We're saying this is the object that was created to represent the page structure and all of its contents. Everything, from start to finish, when we call, dot push on an array, right, we're calling a method of an array. So the this keyword is extremely important because it's special in terms of like, what does this mean for us? This is always a reference inside of an object to the instance of that object. So when we're inside of, let's inspect this page, right? Right. If we do document.getElement IID h, it doesn't have a thing. Get the query selector h1. Right? So that is our first element. Whenever we're inside of this, if we were using this as an option, right? We saw this with add event listener, right? Function, and we say, let's make it click, right? Click, function ev, right? That's our event object. If we do console.log this in here, right? What this means is that when I click on this, this is a reference to the element that was the original one calling it, okay? When we start exploring object-oriented programming on our end, when we start writing classes and objects that we're going to use and manipulate, the this keyword is always going to reference the specific instance of that object. And we'll take a look at how that works here in a second. It is almost always created in our code with the new keyword. And so we're gonna jump ahead and we're gonna write object-oriented code in here for the first time. We're gonna create this as a way to represent the real world. So object-oriented programming, just to give a brief little bit of history, really became a thing in the 90s when software was becoming an important part of everybody's everyday lives, when everybody started getting computers for the first time. All of the code, all of the programmers who are working on this were, our job is almost always to write code to represent real-world things. And so when we're writing a bunch of arrays and we're passing values back and forth in our functions, it gets really easy to get lost in what real-world data object am I trying to model with my code. And a great example of this is the to-do list app. So for the rest of the day, after we go over this, we're probably going to refactor that to be object-oriented, okay? And so the idea in the 90s was, hey, let's embrace the idea that the things we're writing code for represents real-world things, and let's invent a mechanism so that we can do this through, by creating objects, right? So we're going to say things like, everybody in this class, as an example, is a human, right? We are all a type of human. But each instance of us, every individual person in this class, is a different instance of human, okay? So let's write some code and maybe show this off. I'm going to make a new JavaScript file, and we're going to call this OOP, object-oriented programming. I'm going to embed this in the page, so we'll say OOP, OOP.js. Yeah, I'll just keep the other one in there too. What do we call this? ES6. I have some console.log stuff going on here. Let's turn that off too. Console.log. Okay. So now we're going to write some object-oriented programming. Okay. So the traditional way, so this is like the first 15 years of JavaScript, is that objects were created by functions, right? So we would come in here and say function human, right? And maybe we'll do name, age, right? So every human has a name and an age. Okay. And so when I wanted to create a human, I would use the new keyword. So I would say var me equals new human, right? And we put in Eric Harrison 37. Okay. I am creating an instance of human assigned to the me variable, right? And now you see when we type this out here, this is really cool. This is a new invention, is that it tells you the name of the object that it belongs to. So it says human, right? It's a human object. Okay? And that's just by taking a function and putting the new keyword in front of it. Okay? The next thing we would do, right, I'm passing in name and age, right? If you recall, we said that the this keyword refers to the specific instance of this element, right? So if we were in here writing object-oriented code, I would come in here and say this.name equals name, this.age equals age. Okay? And if we call new human now, right, I can go me.age, me.name. Okay? If I was to go and say var Meg equals new human, Meg Harrison, I don't know how old she is, so we're just going to say 20. Good. That's a bit of a joke. I don't know how old she is. Now Meg, right? Meg.age is 20. Meg.name is Meg Harrison, right? We've created, they're both instances of the class human. They both have the same properties, age and name, but they both have different values inside of them. Okay? I could, inside this class, also write a function. I could say function, let's do it as a property, right? So if we wanted to make a method, right? You know how array has a dot push and a dot reduce? I can say this dot greeting equals, and we'll use ES6 syntax here, and we'll simply say when this function is called, it says, well, let's just return hello, comma, I am, let's use our template literal syntax, huh? I am this dot name, okay? So this function now is a method of the human object that we just created, right? So if I do me.greeting, it says, hello, I am Eric Harrison. So this is, at its core, this is object-oriented programming, right? We are creating this would be like a class constructor. Okay, and it's saying I'm creating a class of human so that when I use the new keyword on this, it's going to take that class and turn it into an instance of that object. An instance means a specific, individual, single created class. And why object-oriented programming is so useful is that it lets us really model the real world in an interesting way, right? So, right, this is the human class, right? I can create, function teacher, right? Name, age, and I can say extends human, extends new human, right? I don't think that's the right way to do it. Let's look this up. I don't do this very often. Let's do extends. Yeah, but in the that's what the ES6 syntax. Let's look at W3 schools. They're going to give us the old-fashioned way. Extends. Yeah, whatever. We'll show this off a different way, right? So we'll say teacher.prototype equals human.prototype. Okay? And there's this is a JavaScript specific thing, so I'm gonna have to explain this to you. Inside every object in JavaScript, and you've kind of seen it when we clicked on some of our code examples. If I type var me equals new human Eric 37, right? When I type me into this object, right? The actual object itself has an age of 37. It has a function called greeting. It has a name of Eric. Then it has this special secret prototype object that exists in here. And this exists on each and every element in all of JavaScript. Everything has a dot prototype. And what the dot prototype says is, if this object doesn't have any function or method in it, let me have pretend like I do, right? And so if we look at number, right, new number, let's do var a equals new number, okay, a, right? When we look at number by default has nothing, okay? Unless we put a number, let's put a number here, let's say 5, right? So a is the number 5, but the number object has a prototype that has all of those functions we've been using up until now, right? Same with array, same with any of these things. So every instance of this object gets these special things. And so what we can do in the old way of writing JavaScript for object-oriented programming, we would say, hey, the teacher prototype takes the exact same thing as the human prototype. Or maybe we say new human, right? So we say that when we create a teacher, it is going to inherit everything that human got, right? So let's say function teacher, name, age, right? So by default, teacher.prototype is going to be a human. So if I say var me equals new teacher, Eric 37, me.age, oh shoot, I'm doing this backwards, aren't I? Oh, I didn't declare them. Oh, it's because they're up here. Okay, so you see, this is one of the big problems with the old way of doing things, is that our object-oriented mechanism in JavaScript, in ES5 and before, was kind of convoluted, right? So if we wanted to make things inherit from other things, right, we had to not use this type of syntax. Or we did, right? So if we said, hey, this greeting, right, we would say human.prototype.greeting equals function, and we would say return hello, I am this dot name. And so what we would often do is we would write all of our object-oriented code like this. We would create a class constructor that did just the bare minimum, just the bare minimum. But then what we would do is we would say, hey, human.name equals, human.prototype.name equals null, human.prototype.age equals 0, right? So we would create all of these things in the prototype so that when we created instances of objects, we could inherit, right? We could say, teacher.prototype, let's make a function teacher, name, age, this dot name equals name, this dot age equals age, and then we would maybe do like this dot profession equals teacher. Okay, then we would say teacher dot prototype dot profession equals no, right? So what we're doing here is we're saying that everything that human got, teacher is going to get as well, right? So I could say var me equals new teacher, Eric 37, but it also gets a profession, right? This is a type of, type of me is the object teacher. Okay. This is the old way. This is how we used to do things, for the longest possible time. In order to make an object, in order to make a class in JavaScript, in ES5, in the old way, you would always use a function. When you call the new keyword, like this, new, whatever that function is, it's creating an instance that will then bind the word this inside of any function inside of that object to the object itself. right? That is the main thing to take away here, is that this keyword inside of an object refers to the specific instance of that object that you just created. Okay? Now, ES6 has actually made this way better, way a million times better. And so let's write some ES6, right? So this is the old way. I'm gonna comment all that out. ES6 has kind of stolen this from other languages, right? Because the original prototype-based object-oriented mechanism that came with JavaScript was a little bit different from the way every other programming language does it. With ES6 now, we have a class keyword, and I can say class human and give it squiggly brackets. Okay, and so now, just like with the other one, I can say var me equals new human. Right? Me is now an object of type human. Okay, it's the exact same lines of code. So let's look at the W3 schools and see if they have good examples here. Class, JavaScript classes, perfect. All right. So using this exact same mechanism, right? If we wanted to have values be set when we call our class, we have to use a special keyword called constructor, right? And a constructor is a function that takes whatever values you want, name, age, and then you can set this dot name equals name, this dot age equals age, right? These 9 lines of code is the exact same as these lines of code. If we, okay. It's doing the same sort of thing. We're saying, hey, this class has a constructor. The constructor is the function that is called when you say new and you put parentheses around it, and it takes name and age, and it returns an object, right? So these lines of code are identical. Right. Var me equals new human. Eric 37. Me. Okay. Same exact thing. But now we don't have to use the prototype object anymore. Or it's still available to us, but it's not about how we write our code for object-oriented inheritance, right? So if we wanted to, instead of doing all this prototype nonsense that we were doing down here, I can say class teacher extends human, right? And if there's something specific that needs to go in here, right? Constructor name age, we can say this dot name equals name, this dot age equals age, this dot profession equals instructor or teacher. Okay. So human var me equals new teacher. Eric 37. Oh, I have to call super first. Super. And so now it's a type teacher. Now you'll notice it gave me an error when I didn't have this line in here. Right? It says uncaught reference. Must call the super constructor in derived class before accessing this or returning from derived constructor. So what it's telling me is that I need to call this special function called super. And what it's doing is when I call new on teacher, because teacher extends human, super is going to call and run this constructor to make sure that everything we need is set up and in place. So I could take this out, I think. I could pass in name, age here. Okay. So that I don't have to write those same lines of code. And if we look at me now, name Eric, age 37 is correctly called because we've called the super function. It simplifies a whole bunch of that, like I've got to declare a bunch of prototypes first and then pass things around. This is a very simple way for us to use object-oriented programming to model the real world. And I say model the real world because that's one of the main reasons that you would want to write code like this. You want to say, hey, this code that I'm writing represents some physical object or some kind of theoretical object. Like a to-do list is a great example, right? A class-based system is perfect for a to-do list, right? A to-do list is a list itself. Then there is the list item. Right? Those are two like real-world things where we could create all of the things that are necessary for building a to-do list using classes and object-oriented programming. There's, again, this should be super heavily emphasized that this is just a tool for you to use for writing code. You can write perfectly valid code without ever using object-oriented programming classes. You don't have to do any of this. This is just a way for us to communicate to other people the intention of what we're trying to write. Go ahead, Selena.
For the constructor extend one, should the constructor say name and age, or should it say profession?
It doesn't have to say profession because we're not passing that in. If we wanted to make this overwritable, right, if we wanted to make this different, and human and teacher is a silly example. Let's say profession. Well, we can pass this in as an argument. Profession, right? So now, teacher takes 3 arguments. Human takes 2. So if I say var me equals new teacher Eric 37, pilot. I'm a pilot. We look at me now. The teacher object is created with name, age, and the profession of pilot. The super function is calling the constructor above here, so it only needs 2 arguments. But because we're passing in a third, we can use it in here. The other cool thing about all of these classes, and we'll explore this here, is that the syntax for writing extra functions and stuff is really simple. I can come in here and say, like greet, and we'll say hello, salutation. What am I going to call this? Console.log hello plus salutation. Okay. So now when we create me.greet, yes, it's console.logging hello yes. So all we have to do to keep adding new functions, adding new methods in here, is that we simply, inside of our class, we just write the name, write the function. So this is a different type of syntax, but all of these functions will be available to us in our object. And this is also available in here as well, right? So this, let's do console.log this.profession, right? If we wanted to, it's going to print out whatever properties were set inside this object. If we were to look at me right now, right, you can see that it has the properties age 37, name Eric, profession pilot. Then if you look at the prototype in here, right, it has a greet function that is in the prototype. So behind the scenes, what JavaScript is doing is all that crazy stuff we were playing with before, where we're saying, hey, the whatever prototype, this would be like teacher.prototype.greet equals function salutation. Right? This syntax with ES6, where we just write a class like this and we can put any properties that we want in here, just makes it way easier to build interesting objects with object-oriented programming. Is there anything else important I need to cover in here? Let's see. Maybe the getters and setters is useful. Class, getter, setter. JavaScript. Yeah, they're called accessors. Alright. Maybe we'll cover that later. I'm trying to think of like a good example, but I think it maybe at this time it makes more sense to let's actually work on something we've been working on, our to-do list app. Let's see if we can convert that into an object-oriented type of environment, and we can compare and contrast the 2 versions to see which one we like better, right? Does anyone have any questions before we jump in and start doing that? No? All right. I'm going to go live on this thing so we can see it. So this is where we're at, right? This is the current working version. Here is our code, just to refresh ourselves. All right, so we first grab the lists from local storage. Our list was an array, and gosh, I should have left example of the object. Let's do that here. More tools. Local storage get item lists. Right. Let's JSON parse this. JSON parse. Right. So this is our object, right? So we had an array. Inside each element of this array, right, is a list. The list has items and has a title. Okay. So let's start thinking through. Right. So we grab that information. Then we, when we have a submit event, right, we're gonna prevent the default. We're gonna do something here. All of this code is object oriented in the sense that like we are using objects that JavaScript has provided to us, right? Like the .splice method of an array, right? That's object oriented programming, even if we didn't write those objects. Let's see if we can't simplify this code, simplify this flow, using objects that we care about. Okay. So if I was going to write this, let's say new file, to do hoop.js. Okay, so we're going to write this code using objects as our way to do things. So let's just start working from the top, right? So we need to define our list object, define our list item class. Yeah, we'll call these class. Let's use the right words here. Class. So we're going to define our classes just to set up like what it is we're trying to do, right? And then optionally, we after that, think about implementation, right? So we might do this all in here, or we might just go in and update our to-do.js and use these objects instead. Okay, so a list class, right? So we know that I can write a class list. Okay. So when I call new list, I want to create an object, and so we know that we need a couple of different properties, right? So let's make a constructor, right? List. Let's just call it title. So this dot title equals title. Right, that's pretty simple. And then we need to make a list of items, right, equals array. That was all our previous list had, right? Okay, then we probably want to have on our list object itself, when we create an item, we want it to create the item so that it's put into the instance of itself. So let's create our list class first. So we'll say class list item and constructor, right? When we create a new one, all we need is the list item, right? So we'll say title, I guess. What is like the to-do list text? What would that be called? Yeah, we'll just call it like a value. And we'll say this dot, oh, we named it something in here, didn't we? Lists. Did we already give it a name? Items. Yeah, value. Okay, that's fine. Right. So this dot value equals value, and we also had in here completed is false and timestamp is a new date object. So this dot date timestamp equals new date, and this dot completed equals false. Right. So if I call, if we put this in here in this page, right? Let's put this above here. So we'll say to do oop. Okay. If I was to call new list, and we give it a name, Eric, right? It has created that same type of data object that we had before, right? It's got items in here and it's got a title. Okay. If I was to call new list item, and we say take out the trash, right? That is going to do the same type of object we had before, but now you see this as list item, whereas before when we did it, right, we were making these ourselves, just as like native values, right? It was like it's like arrays, objects, right? So we're actually building real classes now that JavaScript knows about when it is when we display it in the console. It knows that this is a list item. object. Okay, so that's step one. That's pretty good. So the other way we'd probably want to write this code is that we say, hey, the list itself creates the items, right? You can't create an item without knowing what list it needs to belong to, right? This dot items is a value of the list. So what we probably want to do is add a function here, and we'll say add item, and we give it a value. And so then what we can simply do in here is say this dot items dot push, right? This dot items is our array dot push, and we want to do new list item value. Right? So if we were to write new list Eric, make it var list equals right? List dot add item something is calling new list item and putting it into our items array. So if we look at list now, it has the title of Eric and it has a list item in here that says, do something. Okay. So we've just in a few lines of code encapsulated all of the data model stuff that we were doing before, and we've given it like real names. We've said this list item belongs to a list, right? If we wanted to delete an item, how did we delete it in here? Or if we wanted to mark it as complete. Okay, here's a good example, right? So right now, we were using data list ID 1, right, as our values, right? So if I wanted to, I can, if we wanted to mark something as complete, right, mark as complete is going to take a list item index and is going to simply say this dot this dot items. What was it? List item index. Index dot complete. Dot completed equals true. Okay, so when we mark as complete, the list item that is stored inside of here is now marked as completed. Then if we wanted to mark delete item, list item index. Gosh, what was that code? It was a splice one. Yeah, there we go. So this will remove that from the array. All right, so we're saying, hey, this dot items dot splice list item index. We gotta spell item correctly in here too. So now I've just added all these little functions to do what we were doing in here, line by line, right? So if my el.match.done, right, display none, and then we're removing it from the element, right? We were doing that in here as like functional line by line type of programming. Now we're saying we're going to encapsulate all of that logic into a bunch of functions that are going to be properties of the object itself, right? So if we were to, right, come in here and play with this, we'll say var list equals new list Eric, and we say list dot add item do something, list dot add item do something else, right? So if we look at list now, right, it has two elements in the array. If we were to look at those items, right, both of these are not completed, but we know that this is 0 and this is 1. So I could say list dot mark as complete, and we'll say 0. List item index is not defined. Did I type something wrong? List item index. Oh yeah, lowercase l. Oops. Let's do this again. So now if we mark as complete, if we look at list again here, we look at our elements, this one is now marked as completed true. So the only thing, like, just with a few lines of good code, we have encapsulated all of the logic we were doing before, but we still have to link this to our page somehow, right? So we probably want to, maybe even in the, right, so the list is a thing itself. The list item belongs to the list. So what we really need to do is, instead of thinking about implementation, back here on this page where we've got our render to-do list function, right, we would have to rewrite this to take advantage of these new objects. And we're also going to have a problem with local storage because we got that for free, so we'll have to think about that. Think about fixing this with our new classes. Okay, so we're probably going to have some kind of data storage inside of our class itself so that we know, because if we were to take, right, for example, lists, right, list is our object here. Because JSON doesn't understand native classes, right? It doesn't understand our concepts of code here. If I was to just run json.stringify and call list, it's giving us an object here, but this object, if we ran json.parse, I'll pass it in, json.stringify list, right? It is creating it as an object literal, not as our class. So all of our functions, like dot, what do we call it? Remove, get, add item, for example. Add item doesn't work because this object literal does not know that it is an instance of the class list. So we're going to have to come up with a better solution for data storage in this new class-based system. So maybe what I want to do is I would possibly think about defining an app class or an app object that controls data storage and retrieval and can set up these things. But we'll talk about that here when we get to it. All right, so let's think this through. So all of our code here creates these elements. We're attaching things. Let's maybe just start one by one and work our way down. So I'm going to comment everything out. Right? So we have a render to-do list. That was our main function that was calling our page. So let's start there. So, so everything now is done. Let's take out this comment. If we save our code, right, nothing renders. But we have a list class, var list class. So that would be one single list. So we still need an array to store all of our lists that could be there. And so we'll make that right now. We'll say var lists. Let's use let. Well, let's use const. Const lists equals array. Okay. So we have our list object back. Let's see. What was render to do doing here? Render to do list. Because we need those. Well, let's just bring this back line by line. Run function render. Okay. And then we'll call render. I want that. I want this. I want that form that gives us like that nicely designed card that we can start building off of, right? And I think that was in here, right? Yeah, blank list. So I want this, and we'll be up and running. Copy. And I'm gonna comment it back out. All right, cool. All right. So if I put this there, right? So here's another example of using the things that we learned today, right? All of this can be simplified with template literals, right? So I can say lists el.innerHTML equals lists el.innerHTML plus, and then we'll say div class equals blank list card. And we can even do multi-line in here, right? So that's kind of cool. So let's make this look nice and neat. /div, and we'll say h2 create new list, h2 form action equals new list, method equals post form input type equals text, ID equals add list ID, name equals add list. Input type submit, value equals plus. All right, we take this out. All right, so now by using the template literal method, all right, we can create a much cleaner looking output HTML. Maybe we even want to tab that over a bit so we can see that it 100% belongs to this statement. All right, so if I run this code now, yeah, perfect. We're right back to where we started. So I need to attach to this, right? We did it down here with the submits, so I'm still probably going to do that. So let's, where do we declare our event handlers? It was right here. Document.add event listener function event, right? So we're going to declare that same stuff, right? And let's use ES6 syntax here. So we'll say bloop, event, right? Perfect. Actually, let's stick with the old. Let's stick with the old function event. Cool. All right. So we had to prevent default. So let's do that. Event.prevent default. Okay. So when the submit happens, we need to capture this text from here and create a list. Right. So event.target dot add list dot value, right? That's the value of our element. Or we could have done document dot get element by ID add list ID dot value. This value is going to be the name of the list, right? So we can say var list title equals, okay, and then we could simply say lists, right? Because we want to store that in our lists array. We would say const lists dot push new list title. Okay. So I did this in here, right? If we actually look at lists, you can see that it did indeed create a single list called test with no items in. Perfectly exactly what we want. Now all of our render code from yesterday was still pretty good. So we need to render. What else did we do in here? We had 2 loops. Yeah, perfect. Well, let's just copy it because the code's going to be easy enough to borrow. Good. All right. So let's just fix our rendering here real quick so that we are back in business. Let's take out our good. Perfect. So now instead of list.length, right, this list that we get right here, if we say let's change everything over. Let. So let list equals list I. That's correct. Then we're saying we're creating the new list. This is the actual element, right? Then we're creating the title. That was that actual title. Then we're creating the list EL. Then we're creating each of these items, right? So list was our list object. It has an items property that is an array of list items, and it's looping through it, creating those elements. So that all was good. If we want to change this, yeah, let's change this to template literal syntax in here. Li class equals add item. Form action equals list. And so now we get to use the literal syntax, so we can drop I, which is our loop variable for the list, in that spot. Okay. Oop. And then method equals post form li. Good. Okay, inside of here we need our input ID equals item underscore I. Okay, type equals text. name equals item, input type equals submit, value equals plus sign. Okay, so now we take this out. So we replaced that with the cleaner syntax, and then we're appending those two elements that we just created to the page. So if we, yep, perfect. We say test. We called render. Perfect. We get a brand new list. There's still some problems in here. We see that it did not actually create our element. So let's inspect this. Why did it not grab our title? Oh, because we changed the name. Yeah. So our list has a title. This one had it as list title. So we just need to change this to list dot title. Okay. So we type test. Now we run render. Perfect. Test shows up. So we're right back to where we were kind of yesterday. All right. Let's see if anything else is broken. So let's add an item maybe. Oh, we would have to write that code. So in here, when we're writing our thing, how did we check yesterday? We were seeing if. Yeah. Good. On the submit, we're saying if action. Oh, okay. So we got the action. So on this, we need to see, am I on the add item form or am I on the add list form? So we're going to grab that here. So we're going to say let action equals, okay, and then simply, right, it's either going to be new list or slash list, right? So if action 1 equals new list, do that code. Otherwise, else if action 1 equals list, then we are creating the elements, right? Perfect. Does everyone understand kind of what we're doing here? We're just taking the code we wrote yesterday, or last week, and we're turning it into using classes instead of items. And we're cleaning up our code as we go. Now, in general, I probably would have jumped straight to maybe classes. As soon as I knew this was going to be a to-do list app, I would have made these classes in the first place. But we're showing this is kind of a real-world example of we're going to write code one time, and then we're going to continue to iterate on it until it's nice and clean and we really understand and love what we're doing. What this model lets us do is that it keeps our data model separate from our page stuff. Okay, so this is all page stuff. We're building buttons, we're clicking things, we have event handlers, but our application is almost entirely contained inside of our object-oriented model here. And if we transition to writing backend code, if we wanted to do the same sort of stuff, this backend data model would work on our server as well. And we'll show that off when we get to that stage also. Is there any questions with what we've done so far? I'm kind of moving pretty quickly, but I haven't heard anyone chime in and ask what I'm doing, so I've just been going.
No, I'm just following along.
Okay.
I'm picking it up as we go.
Cool. All right, it is 6:05. Let's take another break, rest our brains, get the blood pumping, and we'll come back at 6:20. Okay, 6:20, and we'll finish this out. Start the recording. All right, where we left off, we were kind of re-implementing all of the stuff we'd done previously, but using these classes as our framework for how we're going to build new features in the future and how we're going to store our data and think about this in terms of functionality. So let's just keep chugging along, huh? So we have the page rendering. If we pull this up, right? So create a new list. If I type in some stuff and I call the render function, render, it does indeed create this new list. And we verified that our data model in the list array, does have indeed a instance of a list item, right? So that all was working fairly well. But we need to make it so that when we add list items to this array, those will be added as well. And we also need to, whenever we add an item, whenever we click a thing, we need to re-render our list. So let's just come down here and grab this code, right? So if this is list, Perfect. That's all we need there. So if we paste this in and we uncomment lines of code, all right, so we're grabbing the ID of that form, right, because we're putting the ID of the list in here. We're grabbing that ID, we're parsing it so that it's an integer, then we're grabbing the value. Okay, then this is where we were creating that list previously, but now we don't need to do this anymore, right? So we can simply call lists list ID dot add item, and then put in this value item. Okay. So in theory, did something. Oh. So in theory, this code should work correctly. Right, let's make sure. Yep, add item is the name of our function. Great. So if we type ASDF in here, great. If we type ASDF, yeah, we're getting our stuff back. So everything is back to where it was, except we don't have these hooked up so that we can click on them yet. We had that down here in, gosh, where do we have it? Yeah, right here, our click, right? So we need to solve this still. Okay, we still need to solve this. So we're gonna have to add an event handler for that. So that when we click on our elements, like we want to mark them as complete. Okay. So, how did we get it down here? We want to prevent the default. Yeah. We get the target. Clicking it. Okay, then we're getting the list ID out of the element from the HTML. Okay. Perfect. So let's just copy all this code because this is all good. All good stuff. Okay. Put this in here, and we'll uncomment it, and then fix what needs to be fixed. Good. All right. So if the element matches item, right? We don't need to console.log that. We're getting our list ID. And now that we have mark as complete and delete item, right? We don't need to. Right? So rather than doing this splice stuff here, we can say lists current list ID dot mark delete, what do we call it? Delete item, and we say current item ID. So that line of code is gone now. Okay, and then the same is true down here, right? So instead of putting it as completed, we can say lists current list ID dot mark as complete current item ID. So that line of code is gone. And then instead of calling render to do list here, okay, we want to just call it on both. So let's delete that. So if we've clicked on an item and we've done something, let's recall render. Okay, so if we type in ASDF, good, ASDF. And if we mark it, yep, now that's marked as incomplete, and now it's gone. So we've used that class to simplify all of the code that we had in here sprinkled throughout that was controlling our clicks and stuff. We've now offloaded all of that and put it into a list class and a list item class. And we can continue to work on like actually creating these objects. So the one thing that's outstanding from all of this is that we don't have a way to store this so that every time I reload the page, right, it's gone. And we've also learned that if I was to put some stuff in here, ASDF, right, bunch of stuff, right, our lists array contains the object of the type list, and then the list items themselves are these. When we looked at this, right, var JSON equals JSON dot stringify lists. Okay, lists. The problem is JSON is now purely a JavaScript object, like as an object literal. So we can't do what we did last time and get that for free. We probably need to write ourselves a small little function to load data. And so maybe what I would do at this stage is, oh, that was all of our old code. Let's right? So let's just let's think about that. Let's say right, lists equals an array. We probably can't make it const because we're going to need to be able to override it with whatever comes back from data storage. So maybe we do. Let's think about this. All right. So let's make a function called load data. And we know we need local storage, so we're going to say local storage dot get item lists. Okay. That's where our current stuff is, and I think we still have like the old list in here. Local storage dot get item lists. Yeah, perfect. So it's already there. It's in the right format for ourselves. But what we need to do is when we load this information, we want to create each list item correctly. So let's write our load data, right? So let's say let local list equals that. So first, we can loop through it for local var I equals let I equals 0. I is less than local list dot length I plus plus. Okay, so we're just looping through this array. The very first thing, right, the top level of our array is our list object itself. Right, so while we're doing this first loop, right, each item in here, local list I, this is the list. Right, so we can say var, so we can say, you know, let list equals that. Okay. So we need to actually create a list item and push it into lists. So we'll say lists dot push local list dot local list I dot title. Right, so we just need to we need to do new list local list I dot title. Right, so we're creating our object and pushing it into the list array. Does that make sense? We're creating our object and putting it into the lists array. So if we load this page now, we got to call the function load data. If we looked at, and then we called render again, perfect. There's all of our elements that were, we did something wrong. Ooh, sheesh. So let's see if we can figure out what we did wrong. Local list. Oh, forgot to JSON dot parse. It's stored as JSON. Okay. So now if we call load data and render, perfect. And what did local list I? Let's see what comes back from here. Oh, it's because it's list title in that, right? But that's good. So list title. We used to call this list title. So if we load data, render, perfect. Now we don't want list title to be in here. We want it to be title because that's what we changed our oop to be. This. When we wrote our class, we gave it the name title for its property instead of list title. I think title is probably better, right? We know we're a list, right? So putting the name list title seems like unnecessary extra words. So we're not going to be able to use our class correctly like we want, but that's fine. We can always just make sure that this gets working, and then we'll be able to create that, right? So then we also know that inside of this, for let j equals O, j is less than local list I, well, let's just do it from list here. List dot items j plus plus. All right, so now we're inside our items in the array, right? So what we want to do is add the item, right? We want to call our add item function. So we actually probably need a reference to this element, right? Instead of just doing it. So we'll say let list object equals that. So we're going to do, hey, let's push this to the end, right? So we're going to actually store it once we're done. So we're going to say list object. And I typoed this object. Okay? So while we're looping through the items, we want to create the add item function, right? So list object dot add item list dot items j. So as we loop through this function, right? If we did load data and render, we'd have to show this off. Let's change it back to list title so you can see. There we go. List title. Load data, render, groceries and to do. Let's look at our lists object and see why our items aren't showing up. Items, it's an empty array. Where are our items? Oh, because they were here. It's dot value. There we go. Load data and render. It's still not showing up. That's interesting. Let's look at our list object. The arrays are still not showing up. That's interesting. So we created our list object. Then we called add item. What is in here? Let's take a look at. Let's inspect our data object. All right. So that's correct, and it's got items. 0 is beer, right? So that should all work. So what is wrong with our list here? Add item. List.items.push new list item value. That should be run. List object dot add item. Oh, dot length. We're not counting in our loop. We forgot that we need to go from 0 to something. What I had before without dot length in here was saying list dot items. Well, it's lower than that, right? So that was never going to run. Load data and then render. Perfect. Now we're back to exactly where we were yesterday. But you'll notice some of these, where we were with our old code, are marked as complete already. So we've got a little bit of a bug here in that we did not take this into account when we were writing our code, right? We were just saying add item takes a value. But we probably also need to make some optional arguments in here that will mark something as completed, right? Because we have this.items.push is going to create this thing. So we need to be able to take some value, right? So if we put in timestamp and completed, right? We need to be able to pass these in. So we can use ternary code here. We can say timestamp, if it's there, right? If timestamp is passed, we want to do new date and put in the timestamp string. Otherwise, new date. Same for completed. We want to say completed, question mark. If completed is passed, and it's false, so we can do this. We can do completed. It's either going to be true or false. So if true is passed, great. That's the default. Otherwise, if we pass in false, it's going to be false or false. So this should mark it as. So now, when we're in here, where we'd have new list item, we want to do the same thing. We want to do timestamp and value. All right, timestamp and completed. And then we'll do this, timestamp and completed. So now, in our code where we're setting this up, we can simply say add item, and we'll put in list.items j.timestamp and list.items j completed. Right, so if we call this now, load data and render, yeah, we see one is completed. That's good. And the timestamps are in there correctly, so we're not just creating new dates all the time, if we cared about that, which we probably will if we want to keep making features and making functions into this to-do list. Okay. Then the last thing, right? So we got our list item being created correctly. We're putting it in the list object, so we probably need the load data function to be called when we load the page. So right before render, load data. Okay. Then every time we add something, so in our submit, we probably need a function that will figure out a way to store this object in a way that we can use it. So we've already got it, right? So we can do the same thing that we had here. What was that? So whenever we make changes in here, right, we want to, before we render those changes, we want to local storage dot add item, and we'll call it lists, and we'll do JSON dot stringify lists, right? So our main list object. We'll leave a comment here. Store our lists object as a serialized JSON string. Okay? So that we'll always get that storage effect back. Now this is going to break because when I load this page, we're still using list title, but if I added new elements in here, right? Add set. What is the local storage? Local storage. Set item, not add item. Perfect. So if I was to add this now, right, you'll notice test. Right? All of my titles will go away because we're storing them with the object orientation that we have here. So we need to change this back to just regular old type. And now they're all back. So we just migrated our entire product in the span of 30 minutes or something to use classes and excellent object orientation rather than HTML. So now what I would do if this was a real product that I was developing, all of my features on those lists are going to happen as functions in here. I'm going to write a completely separate JavaScript code where I'm adding list items, and maybe I've got different types that are like a drop-down list or a color picker, and I want to be able to store each and every one of those values. I would do all of the functionality stuff for the data model in here. And then when I'm just building and working on the HTML side of things, when I'm making it so buttons are clickable, that's going to use those data objects, create new classes, create new instances of objects. And it helps you build a more maintainable product because we've got our data stored in a completely separate, we've got our data model built using classes and object orientation that matches kind of a real world model of what we want our objects to look like. Any questions about this? Any questions about object orientation in general, or like object-oriented design? You see, this does exactly the same thing that we had before. It's just a different style. It's just a different way of writing code. Neither one is better or worse than the other. No questions? All right. Has anyone over the weekend made any progress on making your to-do list apps functional? The ones that we started working on last Monday. Do you have anything to show off now, or would you like to spend some time working on it in class today? I think it's important that we start practicing some of the techniques we've been learning to try and turn a web page into a web application. All right, it is 6:40. What I want us to do is for the next hour until 7:30, I want us to take our to-do list app and start building it to actually be functional. So all the prototypes you guys worked on last week, like Josh, yours was like a smoker or something, right? Or some kind of thing. All those things that you guys put work into already, let's actually start during class time to work on that now. So at 7:30, no later, because we're going to be out of time, we're going to do a show and tell. Show off how far you've gotten, show off, I'm able to store elements to the page. As far as you can get in the next hour, let's go and do that. So 7:30, we'll come back. I'm going to be here the whole time. So if you get stuck, if you have any questions, any problems, don't bang your head against the wall. Don't do nothing for an hour because you've got a syntax error. Ask for help. That's what we're here for. Okay?